All right, that should be good. It's 4 o'clock, we'll get started. This might be a shorter recitation just because 1, no homework, do this Friday. Well, no, big homework, do this Friday. And 2, the exam's over. So a lot of people don't want to come because they're like, oh, we already learned everything. So today we're just going to focus. There's not really much that I can lecture on because we're on chapter 5 now. And Jason hasn't gotten too much into chapter 5, and so I don't want to start teaching stuff that he hasn't done yet. So we're actually going to jump straight to problems, and this will be from homework 5.2, which is due on Friday. So I'm going to give some hints on this one, and then I'm going to open it up to questions if you guys want to ask any questions about this homework, or maybe you're ahead and you want to talk about 5.3 or the big chapter homework due next Friday. And just in case you didn't hear, because of the Jazz Fest, nothing on Friday, no class. He's going to do a YouTube and upload it to the same YouTube channel that I upload these to. And then your homework assignment, he said he didn't remember. I should look at it.
Is it next Friday?
Yeah, next Friday. Okay. So next Friday, no class, and then Monday, no class because President's Day.
Wow, so only Wednesday.
Only Wednesday, and he won't even be here for Wednesday, so it'll be someone else teaching.
So let's spice it up a little bit.
Yeah. So it might be me or one of the other TAs teaching on Wednesday, but we haven't decided on that. Okay, I can't pull up the homework for 5.
Well, I was looking at the next section. And,
oh, there we go.
Do you think you'd be able to offer any advice for trying to get ahead?
For 5.3, you mean? Yeah, I can. I'm going to do 5.2 first, and then we'll move to 5.3.
Snowball one threw me for a friggin' loop.
Oh, yeah. He specifically told me this morning, he's like, that's a trick question. You might need to help them with that.
I didn't realize that until like later on.
Yeah.
Just the way I got like a 0.2 out of 0.5.
So. Okay, yeah, so it looks like homework for chapter 5 doesn't have a hand-in, like a physical paper hand-in one. So on Friday, you don't even need to go at all to hand anything. Next week. Yeah. I mean, I'm not going to tell you not to go on Friday. Well, the TA said that we didn't have to go, so. Okay. So let's look at the snowball one. So it is asking, so it has all of these, and the reason it's a trick question is because it gives you all this information that you don't need. So you have all these snowballs. It specifically says the 3rd graders versus the 4th graders. They're in a snowball fight. Once it gets into that, you already know it's too much information because it's just like, why do we care who is having the snowball fight? But they're throwing the snowballs at each other, and then it says, rank the snowballs A through E according to the magnitude of total force exerted. So you have all these snowballs. I'm not going to draw the vectors that they do. I'm just going to draw the magnitudes. So you have 5 snowballs. This is their velocities. You have A, B, C, D. So 9, 12, 12. 10 and 8 meters per second. Then their masses, 400, 300, 200. This is 400, 300, 200, 500, 400. Grams, 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 grams. Okay. And then it asks, what is, so this is them throwing it. So this let's say that this is me throwing it this way. So I'm throwing these balls, they're all going different directions, but all in this plane. So they're all going in this plane. Now it asks what the total force magnitude, total force exerted on each one during the instant captured in the figure below. So in this instant, This is going 8 meters per second, 10 meters per second, 12, 12, 9. The acceleration in this instant for all of these is 0. So 0, 0, 0, 0, 0. So in this plane, so meters per second squared, etc., there's no acceleration. There's a force if it hits someone because you have a deceleration, so you have transfer of force. But while it's in the air, going at a constant velocity, there is no force in that direction. So then what does this question mean? So it has all these velocities, but you're not even going to use any of them because it's specifically asking for force. Force equals mass times acceleration. Well, there's only one acceleration, and that's gravity. That means that you are organizing these based on their forces. Since all of them have the exact same acceleration, you are then organizing them based on what? Mass. Just mass. So this is A, B, C, D, E. And I'm not going to finish the problem for you, but that is basically it. As long as you catch that trick, you should know, wait a second, velocity doesn't matter because velocity has nothing to do with force. The only acceleration is down, is in the plane. So you're looking at the snowball fight from the top, and it's tricky because you have to realize, wait, there's gravity as well. That's where the force is coming from. So no force vector in this direction, but there is a force vector in all of them down. Okay, so that's it for number 1. Are there any questions for that one? Okay, that one should be pretty straightforward. Number 2 is you push an object initially at rest across a frictionless floor with a constant force from a time interval delta t, resulting in a final speed of v for the object. You repeat the experiment, but with the force that is 6 times as large. What time interval is now required to reach the same final speed v? So let's just think about this as a thought experiment. This one's fairly easy, so I won't go into it too much. So you have a force that's applied to something, an object, over. I guess I'll write this. You have some force. We'll call it F1, and it's applied over a time equals delta t. Let's draw a little picture. So you have this object, and you apply a force, and it's on a frictionless force, so you apply a force and then you stop moving it, and then it has a velocity of v. So this is going to be your delta t. This force is being applied over that entire time, and then you have a velocity of something. This is m1, it's going to equal the other one. Now it's saying that you have a force 6 times as large. What time interval is now required? So you're pushing it harder. So you can automatically assume, okay, I'm pushing it harder, I'm giving it more force, so it should technically require less time to get it to that velocity. So now you have F equals 6. I think it's 6. I guess it's different for everyone. Mine says 6. So to get to that same V. So the delta t will have to be less because you're pushing it with more force. That rules out 12 delta t, 6 delta t, and delta t. Automatically. It has to be less. So there's only 2 answers that's possible. And I'm not going to tell you the rest because there's only 2 answers. I narrowed it down from 2 answers, 2 possible answers. But just know that if you're pushing something with more force, it's going to reach that velocity faster. It's going to take less time. Yeah?
Logically, the problem made sense to me, and I got it right, no problem. But like, I don't know the math behind Like logically speaking, you have, let's say, 3 times more force.
Mm-hmm.
It's going to take, it's going to get there 3 times faster.
Okay, I'll show you the math. Mass and acceleration. You are accelerating it. You're not changing the mass, right?
Right.
So you're increasing the acceleration by 6 times. So if you are accelerating something 6 times faster, so if gravity was instead, instead of yeah, so he's kind of going on it. So if you drop a ball at 10 meters per second squared, it's going to take time t to enter it. If I'm at 60 meters per second squared and I take it, it's going to drop a lot faster because I'm accelerating it 6 times faster. Specifically, if this is, so now you have the velocity, right? The velocity dv dt equals a.
Yeah, the change velocity with respect to time.
So if I am doing now, if I have the same time, let's do it like this. Let's do delta v. Delta v over delta t. But now it equals 6a. I have to somehow decrease, because I want the same v, right? So I actually have to make the delta t, so this is now going to be too fast.
I was trying to do F equals ma and then changing ma to velocity, change the velocity would change the time, and then trying to figure out how to put the integer in there somewhere.
So yeah, the main thing this does,
multiplying the force times the number.
it doesn't change the mass, it only changes the acceleration. And it changes the acceleration by this much, so the time has to be reduced by that same amount.
Right. So even though it says it's 8 times the force or whatever, you don't apply that. You don't write like 8 times F.
Well, you do, but mathematically, you're not increasing the mass at all. Like if I'm pushing something, if I'm pushing an object 8 times with 8 times more force, I am in no way increasing the mass of that object. I'm increasing how fast I'm accelerating it. So physically, it's applied to the entire force, but if you break it up into components, it's only going to be applied to acceleration.
Right. Okay.
Does that make sense? Okay.
Thank you. That helps.
Are there any other questions on that one? Okay, let's go to the next one, which is 5.3, which is due on Wednesday. And then we won't go over the chapter homework too much because there's a recitation next week. I want to have something to cover. Okay. So I'll erase this one. And some of these concepts might not, especially this one I'm about to go over, might not be understood yet because he hasn't lectured on this yet. But I'll try to give you hints in a way that makes it so that's not an issue. We'll see how it goes though. Okay, so if you're looking at it, I guess I can draw a picture of it. So it has 2 blocks, 2 and 1. One is smaller than the other. So we have 2 and a 1. They are an unstretchable cord. It is unstretchable. Do not stretch it. Well, you can't stretch it. And then a chord A. Basically what it means by unstretchable is it's a fixed distance in between it. It's not like challenge accepted and you just try to stretch it. Okay, how does the magnitude of the force exert it? So basically what's happening is someone is pulling on this right here. Applying a force right here, which is pulling both of these things. So directly horizontal force, at least that's what it shows in the picture. So you're tugging all of this to the right. How does the magnitude of the force exerted by chord A on block 1 compared with the magnitude of the force exerted by chord B on block 2? Is it larger, smaller, or equal? Okay, so how much force is being applied here? So force here equals m1, right? An acceleration of 1. So that's the ma. Force B, so the force here, still going to be a1 because they're all accelerating at the same. But then you have, sorry, this is m1 plus m2, a1. And then FB over here is only pulling 1. So the question is, which is larger? And well, one includes everything from the second one, so you have to assume that that has to be bigger, has to be larger. So the magnitude of the force exerted by chord A should be larger than B. How does the acceleration of block 1? I don't want to do all these though. I want to give you something to do. So we'll just look at B and then I'll leave C to you. How does the acceleration of block 1 compare with the acceleration? Oh, I already said that. It is equal.
Does that say A1 after the
Yeah, they don't need a 1 though. I just am used to putting indices on everything.
I just couldn't see it from here, so.
Okay. Yeah, so I already answered part B. The accelerations are equal, and the only reason they're equal is because they're physically attached to each other. You guys remember the lab that we did last week? And if you do the Velcro side and they stick together, the velocities are going to be the exact same because they're stuck together. Like the other cart can have a different velocity than the other. They have to have the same because they're attached to each other. Okay, I'm going to skip C. It just says, does chord B exert a force on block 1? If so, is it forward or backward? Is it larger, smaller, or equal in magnitude? So I'm going to leave that one to you. So what does chord B do to block 1? Okay, question 2. As shown in the figure, okay, you have some students like tug-of-warring. Has anyone looked at this one yet? It has like these kids fighting on a pulley or something. This is not good schoolwork. Okay, so you have, I'm just going to draw it without all the students. So you have 3 points. You have student A, so this is A, this is B. You have like a pulley, let's see. So there's a girl here, weighs 55 kilograms, and student B is 80 kilograms. And oh, this is a fun one. So basically what happens is you have a rope that goes from here to here, and then to this person, I think is anchoring it. A rope runs from student A's hands around a light pulley to the hand of a teacher. Yeah, so this is a teacher who cannot move. So these two can move, this one cannot. That's fixed point. Okay, the low friction axle of the pulley is attached to a second rope held by student B. All ropes run parallel to the chair runners. So they're on chairs. Basically the premise is they're on chairs and one's pulling, or they're just like holding it there. And then all of a sudden, student A is going to pull on the rope, right? So if student A pulls on her end of the rope, will her chair or will B's chair slide on the floor? So you have this force initiated here. Remember, this is a pulley here. So it's anchored here and then there. So you look at this and you say, okay, well, this one weighs more, right? So this one shouldn't move. But you got to be careful because there's 2 points over here that are connected to this 1 point. And this one can't move. So you're actually dividing the mass experienced between these 2 points. So she would actually only be pulling half of the weight. Because it's a pulley, she pulls, and she only experiences 40 kilograms. So the answer would be B. The B student moves. And he probably has a B in the class too. That's why he's called the B student. If instead the teacher pulls on this rope end, which chair slides? So if the teacher pulls, does A or B? Okay, that's a terrible question. So if the teacher pulls, who's going to move? A or B? B, yeah. you can't move A. I guess you could. It's a pulley, but same concept. 40 versus 55. Okay, and then there's a C and a D, and I'm going to leave those to you. Same concept. If student B pulls on the rope, which chair slides? So instead, this person pulls. Does B or A slide? And then now the teacher ties his rope into student A's chair. Student A pulls on the end of the rope in her hands. Which chair slides? Okay, that's an interesting one. So instead, there's just one rope between them. A pulls, which slides? So that's C and B, or C and D. So hopefully I've set this up in a way that you can answer both of those questions yourself. But that is homework 5.3. And are there any questions concerning either of those problems?
Can you actually go, like, you don't have to, like, go through, like, C really quick? Explain that really quick. It's like, I'm not exactly sure.
Okay, so this one is the opposite of what just happened. So student B is now pulling on the rope.
So is it still, are we still considering that it's like half his weight that basically is pulling on, or just like the full 80?
So it's still half his weight because there's 2 anchors.
Okay.
So that should answer that question, right? So all three of, so the first 3 questions, B moves. There you go.
So the teacher doesn't move on any of them?
No, the teacher's standing up. Yeah, the teacher's standing up, and then the other 2 students are in chairs that can move. And then the last one is he ties his rope to hers, and so now there's only 1 point. And so it's no longer divided by between 2 points, and hopefully that one makes sense of which one would move then. Which is D, which I will not answer. You guys have to answer. But I basically answered it. Okay, any other questions about that homework assignment? Okay, I'm now going to open up to any homework assignment. And if there are no more questions, we're going to be done because there's nothing else to do. Are there any other questions? Anything? All right. Well, I will see you guys next week, and hopefully your tests are graded by Friday. Potentially your tests will be handed back in recitation, not in the class itself. But Jason will let you know. Actually, Jason will be there on Wednesday. Someone will let you know when it will be handed back, but most likely in recitation. Yeah, so I will see you guys next week.